Hey students, this is Mr. Ravenscroft, and I'm here to teach you guys how to handle exponential growth and decay word problems. If you're on IXL, this is topic X5 in Algebra 1. Shows up in many of the different subjects, but in Algebra 1, X5, and the shortcut is UKG. UKG. All right, so first off, if we're going to avoid memorizing something that's going to be here for a moment and gone shortly after tomorrow, maybe another hour later it's gone, sand kind of knowledge, then we really need to understand this without any sort of formula. Okay, so let me make up a quick example. Similar to this one up here, I noticed I said something about 10% every year. Let's imagine you had a savings account. I'm just going to call this an example real quick. A savings account that actually had $100 in it. I'm going to say your savings account was a big circle. Okay, so you had $100 in there, and the bank says, hey, every year we're going to, your account's going to gain interest. It's going to compound annually 10%. It's going to gain 10% of the money that's there. So whatever 10% is, that's what's going to get added to it. The next year, whatever the new amount is, they're going to add 10% to that. Let's see if we understand this using this easier number. Easier numbers promote understanding. Hard numbers kind of help us get lost in really trying to understand it. So an easy number. So let's imagine you're going to get 10% of this at the end of 1 year. So I'll make a little chart here. So let's just say this is like Y for the year, YR for the year, and this is like how much money you have. So on year 0, the first year you put it in there, you had $100. After year 1, you would actually say that you have, let's think about that, 10% of $100. So you imagine 10 slices here. Some of you would just think, wait a second, 10%. Percent means out of 100. So when I take 10% and I get rid of this percent sign, what I have to do is move the implied decimal point over 2 spots because I'm dividing by 100. Dividing by 100 moves it over 2 spots. Dividing by 10 moves it over 1 spot. So quick review of decimals there. So we could take 10% times a number to figure out what 10% of something is. If finding 10% of 100 is not natural for you, I will show out how to work it out. And eventually you'll hit numbers that are probably harder. So we'll show it out. Okay, in your product, what's being multiplied, there's 2 digits after the decimal. So we need 2 digits after the decimal up here. And we can say that 10% of 100 is 10. This little piece here, it's $10. And it also represents the same thing as 10%. So we chose numbers that are easy to work with. Percent means out of 100. So what's 10%? What's 10 out of 100? Out of $100, it's $10. Okay, so our new amount after 1 year would be $110. Now, if we kept this pattern up, what would you do next? I mean, in a way, didn't you take this times 10% and then add that to 100? It'd be neat if we didn't have to have 2 operations for that first move we just did. What if we could actually find a way to just do 1 operation to get from 100 to 110? Think about what you just did. You said you needed, to get your year 1 balance, you needed $100, that's all the way around, plus an extra 10%. So if you want $100 plus an extra 100% plus an extra 10%, you could actually say that to get the year 1 balance, you needed 100% plus another 10%. So you really needed 110%. How do you write 110% as a decimal? Get rid of the percent sign. That means you got to move it over 2 spots. Wouldn't it be 1.10? Okay, so that's 110% written as a decimal. I wonder what happens if we would have taken 1.10 times 100. Let's give that a shot and see what occurs here. See if it can get rid of one of our steps. So imagine this. We take 1.10 times 100. So bring our decimal point down. Okay, multiply the 1 times 0. Oops, we got 2 decimal points here. 1 times 0 is 0. 1 times 0 is 0. 1 times 1 is 1. And you could type these in. This is a calculator allowed topic, most likely, in most of your math classes. Holy smokes, we got $110. This was 1 move. We took it times 1.10, and we actually got the final total for this first year was $110. This is the heart and soul behind the exponential growth and decay formula. It's the idea that we're going to multiply by one number that takes us to our new grown amount. Okay? So how we did that was we took what really is mathematically 100% when you move the decimal over is really written as a 1. And then we added our rate, which moves the decimal over 2 spots. So we really took 1 plus r to get that number that we could multiply times anything. So that is the growth amount. That's the base that keeps getting multiplied each time. We could multiply by 1.10. We could do that again, 1.10. And if you take 110 times 1.10, let me see if we can type that in. I'll just speed it along here. If I multiply this, type it in a calculator, let's see what we get. I'll type it in here. 110 times 1.10, we get 121. So added about $11 of interest, which makes sense. 10% of 110 is 11. So we could keep doing this and figure out how much we'd have after 2 years. It'd be $121. Or we could notice something. You're repeatedly multiplying by the same amount each time. So if somebody said, hey, how much money would you have after 2 years? I'd be tempted to say, well, here's my starting amount, 100. I basically need to multiply it times 1.10. That's the growth factor. That's the base that it keeps multiplying by. I need to multiply that by 1.10 twice. That's basically what I did, right? Took it times it twice. So I put an exponent of 2 because that just means 1.10 times 1.10. So what we're trying to do right now is not very common for a lot of students. It's to actually try to avoid memorizing some formula that makes no sense to you. We're trying to build an engine in your mind that you can use when you're 80 years old, because it's not sand, it's not something you memorize, it's something that just makes sense to you. You could rediscover the formula. The good news is, if this first 5 or so minutes of explanation has been kind of a struggle for you to understand how we're deriving this formula and discovering it, you can just use the formula and look it up when you need to use it again, and that's okay. A large percent of people do that. So with no further ado, I want to go ahead and summarize the formula with you right now so that we can start using it on our actual problems. So here's what the formula would say. To put it all together, it would say that you're going to take, to figure out the growth or the decay, that's what y is equal to, you're going to take how much the amount you initially have, so we'll call it A for amount, and we're going to multiply it times the growth factor. That growth factor is like, if it's growing, it's like, well, you keep 100% of it and then you add some more. So that's the 1 for the 100%, that's this part, plus whatever percent it's growing. So we call that the R, the rate. And that gives you this base that you keep multiplying by. For us, it was 110%. How many times you multiply it by, that depends on the problem, but a lot of times they'll say it's compounding annually, which means every year it's growing. So t for time would be the appropriate exponent, because it kind of depends on the situation how many times you multiply by that growth factor. Hey, this is the formula worth writing down. We kind of discovered over here with this little example why it worked. But now let's go ahead and look at some problems and empower you guys to hopefully take back your peace and understand how to do these in a way that just makes sense to you. So here we go. Let's go ahead and take a look. Okay. Our first problem says a scientist is running a simulation of a hypothetical city. Since she wants to explore its environmental impact over time, the city's population is increasing, that's important, by 10% every year. And there are currently 150,000 people. And then here's the question, what will the population be in 17 years? If you could make a little chart of this, I'm kind of picturing we have year 1, and we start off, at year 0, it's 150,000 people, right? To get from year 0 to year 1, it's increased 10%. This is similar to our example. So we could say you multiply by 1 plus the rate, right? So that's like keep your 100%, keep the 100%, and then add an extra 10%. So we could say that if you have 100% plus 10%, you would get 110%, which as a decimal becomes 1.10. Or written this way, you can make your rate a decimal point and say our rate is 10%. And so 10%, let me switch over here so you can see where I'm coming from. 10% as a decimal would be 0.10. And so you add 1 to that. Since we're growing, we're gaining, we keep 100%, that's the 1, plus 10 more percent, that's the 0.10. Our growth factor is 1.10. So this is what they're multiplying by. And if you take 150,000 times 1.10, we would actually get how much it's grown in 1 year. So the math is actually pretty simple here. You could do this without some fancy formula. But if you're going to have to keep multiplying by this over and over and over again, it's probably going to be easier if we say how many times we're going to multiply by 1.10. I just typed it in. I typed in 150,000 times 1.10, and I got an answer of 165,000, which makes sense to me. That means it's gained about $15,000, which 10% of 150,000 would be 15,000. So this is actually year 1, but we need to go ... skip a long ways all the way down to year 17. So here's my question. Like the formula makes sense to you. How many times am I going to multiply by this 1.10? I multiplied by it once to get from year 0 to year 1. If I go from year 2 to year 3, I'm going to have to multiply it by 1.10 again. ... all the way down to 17. Aren't you going to have to multiply by 1.10 a total of 17 times? You see, if we were to label the formula would say that the time is 17. This 10% gives us our rate of 0.10. And our initial amount, we'll call it A for amount, is actually 150,000. The formula would say this. Ready? Let's set it up. Take your initial amount and multiply it times your growth number, and then take that to the power of t, which is just how much time you have, however many of those you have. So let it make sense to you. We would take 150,000, our initial amount, and we're just going to multiply it times, okay, we already figured out that the 1 plus 0.10 would give us 1.10. So we're going to take 150,000 times 1.10, and then we're going to take that times it 17 times, which we usually just use an exponent there. That's the t part. Sorry, that was supposed to be a 17. If you type this in, you'll get your answer. It's big, it's ugly, but it's pretty amazing and it's pretty powerful that you can get that big of a number. This is exponential growth. It's pretty exciting. So let me type that in over here and look at our answer. It looks like the answer we get there is kind of large. 758,170 point. Now there's 5, 4, 2. I'm going to have to, this is talking about round to the nearest whole number. So 0.5, that's going to round this up to 71 instead of 70. All right, so 758,171 people. All right, we have built an engine. We're trying to understand this and not just make it as clean and neat as possible and just give you some formula that makes no sense to you. We're trying to kind of understand it with the table, trying to understand why we're doing what we're doing with the formula. But now we're going to go into another problem and package this up just a little bit more. Let's look for another problem that's a little better. Okay. In this problem, it says the company Ayana works for is seeing 25% growth every year. Okay, that's their growth amount. If the company makes 910,000 this year, what will the annual profits be in 2 years? All right, so I like to just go ahead and label everything. There's my time. This is the rate, or it gives us the rate, which we're going to convert to a decimal and make it 0.25. And this is our initial amount. We'll call it A. So let's take our formula. And at this point, if the formula is not making sense still, it might over time, but you can still use it. Okay, just go ahead and keep using the formula. It's all right. So the formula says take your initial amount and multiply it by some number repeatedly, right? And that number we use is 1 plus your rate as a decimal. And then you're going to multiply that growth amount, this base, however many times you need to, right? For us, it's 2 times because there's 2 years. So let's plug in our numbers, and looks like y is going to equal, our amount is 910,000 times 1 plus, okay, the rate is the 0.25, so our growth amount will be multiplying 910,000 times 1.25. The 1 gives you the 910,000. That's 100% of 910,000. The 0.25 adds another chunk onto it, and that's the amount it grows. How many times we multiply it times 1.25? Well, our t value is 2, so we just plug in 2. All right. Hey, for your final equation you're typing in, on a calculator, you'd say 910,000 times 1.25, $1.25 to the second power, and that should give you your answer. Let's type that in. Okay. As we type this in, one little note I want to tell you guys real quick. If I was typing this on Google, I would start here with the 910,000, and then I would use the multiplication symbol. If you're not sure where that's at, you press the shift button, and it's that little asterisk above the 8, so shift and then the 8 button. And then to go to the power of, this symbol here, this light green one, this actually means, some call it a caret, but it actually means to the power of something. So that's how that implies, that's computer code for putting the next number after this caret in the exponent. So that's how you type that in. When you type that in, you get this answer over here. So we'll go ahead and submit that one and find our next example that's maybe a little bit different. Okay, we're going to look at a couple quick examples here, all very similar, but in some ways just slightly different. So in this one, it says a number of bacteria in a colony doubles. That means like it gets multiplied by 2 every 86 hours. And there's currently a population of 180 bacteria. That sounds like the initial amount of bacteria. What will the population be 258 hours from now? So how many times is it going to double? So you got like 86 hours, from 0 to 86 hours. Okay, that gets multiplied times 2. And then you have another 86 hours. What is that, 192 hours? It's going to double again. And then you're going to go double it again, and or add another 86 hours, and it'd be 258. So it looks like it's actually going to double twice. So we could just go ahead and take 180 and multiply it times 2 3 times. Now, if you look at the formula for this, it's going to be a little confusing because it's going to say on explanations for this that you need to figure out how much it's going to double by taking the time that it takes to double, and then you're going to divide it by the other number, 258. But let that make sense to you why you're doing that. You're just saying, how many times does 86 fit into 258? And if you divide it and you get 3, well, that just means that, hey, there's going to be 3 times that it doubles. So our equation looks pretty similar. We just say the amount, which is the 180, and then we're going to multiply that times 2, right? How much it's growing by. And the time, the exponent here is actually going to be 3 because you're doing that 3 different times. Okay, so there's another example. Let's take a look at another one here. Aha, I found it. This is one of the last problems I wanted to make sure you guys saw before we wrap up this topic. There's a common chemistry term of half-life. I'm almost at my half-life, so I might have half my life gone, half of my time left. So half-life in chemistry is actually talking about if you have a sample of something, it's how long it will take before half of its mass is gone. So let's read it. You have 288 grams of radioactive kind of tellurium. How much would be left after 39 minutes if its half-life is 13 minutes? So let this chart make sense to you here. I think we're saying that this is time and this is the grams of this weight of radioactive tellurium. Can barely say that there. Then we would say that at 0 time it's 288, but once half-life is 13 minutes, once 13 minutes have gone by, this thing has been cut in half. They're going to multiply it by 1/2. And then once another 13 minutes have gone by, a total of 26 minutes, it's going to be cut in half again. So you just need to figure out how many times am I multiplying 288 times 1/2, right? First time you got a 144, you multiply it by half again. So if every 13 minutes it's cut in half and there's a total of 39 minutes left, why don't we just take 39, divide by 13, and that'll tell us how many half-lives it has. So 39 divided by 13 is 3. And now we can go back and say, okay, let's take 288, our initial amount, times, I'll put y equals here, y equals 288 times, okay, our decay amount is 1/2, and we're going to do that, let's see, 3 times. So that would give us our final answer for that one. Okay, it is time to let you guys try this one. This is a more challenging topic, so be graceful with yourself as you try these. Let me know if you have questions. Just add a comment or send me an email. Real proud of you guys for tuning in and trying these with us. I'm excited to see you guys rock it out with a whole lot more peace. Hopefully it makes a little more sense to you. All right, see you guys. Love you all. Bye-bye.